Good evening or afternoon. We are looking at 11116 rendition of PreCalc. So we're on Monday and it will be discussed in class on Tuesday. So watching this matrix, you will learn how to find the inverse of a matrix. You'll see why we want the inverse next time, but we'll just go through the mechanics tonight of finding the matrix inverse. All right, let's chat. Let's have a little chat. That sounds nice. Suppose we had a number like 6, and I want to add something to it to give me 0. So let me zero in on that. 6 plus something equals 0. So obviously it's -6. So we have been told in the past that -6 is the inverse of the additive inverse of 6. So it's what you add to 6 to get 0. And 0 is called the identity for addition. So what do you add to 6 to get the identity for addition? So let's look at matrices. So I want to figure out what, first of all, before I talk about the inverse, let's talk about this. We start with a matrix, we're going to add something to it, and we're going to get the identical matrix. What would that be? Well, it probably isn't going to stump you. Because what would I add to these elements to get this? The identical, the identity. So would it not be zeros in all the entries? So just like up here, this is called the additive inverse, the additive identity. The additive identity, this is the additive identity for a matrix. So it's a matrix with all zeros in its positions, and so when you add the 0 matrix to a matrix, you get the identical matrix. All right, let's talk some more. Let's go to where we're going to stay tonight. 6 times something gives me 6. So the actual number that is the identity when you're multiplying looks like this. We would say, what times 6 will give me the identical number I started with, 6. So looking at this discussion first, what times 6 will give me 6? 1. So whereas 0 was the additive identity, 1 is called the multiplicative identity. All right, and these are words you've heard somewhere in your math past. So over here, I want to know what is the actual number when I have a 6 that I will multiply 6 by to get the identical number I started with. 1. 6 times 1 is 6. So that's the multiplicative identity. And what I was trying to say that second time is going to be 6 times what will give me the multiplicative identity. Excuse me. All right, I'm back. So 6 times something will give me that multiplicative identity 1, and from our experience, we know that 6 times 1/6 is 1. So 1/6 is called the multiplicative identity of 6. When I multiply 6 times its multiplicative identity, I get the identity for multiplication. All right, fancy words for unfancy ideas. All right, simple ideas. All right, so now, whereas up here when we were adding matrices, it was clear what was going to be the identity that I would add to get the identical matrix. Multiplication, it may not be so clear because of the algorithm involved with multiplication. So it has been noticed that what matrix times this one will give me the identical matrix that I started with. And that turns out to be this, starts with a 1. in the first position. On the second row, there's a 1 in the second position. And in the third row, there's a 1 in the third position. That actually works. So let's check a couple elements. This element is in the first row, first column, so that will involve this row and this column. The way we learn to multiply, 1 times 1 plus minus 1 times 0 plus 0 times 0 does give us 1. Let's try this number here, 6. So 6 is sitting in the third row and the first column. So we're going to use the third row in the first column. That's not a minus there. It looks almost like it. It's just my bracket edge. All right, 6 times 1 plus minus 2 times 0 plus minus 3 times 0 does give me 6. And if you check it out, it does work. This is the multiplicative identity for matrix multiplication. All right, so moving right along, I am going to teach you today how to find the matrix here. So when you multiply the given matrix by its inverse, you will get the identity for multiplication. And this is the identity. So we want to find out what you multiply this by to get that. So that's our goal tonight, today, this afternoon, this morning, wherever you are in time. The way we do that, we're going to find the inverse of this matrix. Then we'll multiply this matrix by it and see if it doesn't give us that identity that we're looking for. The way we do it is we make an augmented matrix where we copy the matrix that is the problem and we add to it the identity matrix, all in one big happy matrix. So there is our identity matrix for multiplication, and this is just to help us line things up. It doesn't have to be there. Let me zero in. All right. Now we are going to use our row operations and create this over here. And when we do that, the matrix over here, the new matrix that appears on the right, will be the identity matrix. So, all right, so when we're doing our rows, actually it's going to have to be reduced rows. Reduced row echelon, here we come. All right, so the first thing that I'm going to do is I'm check and see if that's a 1. It is, so that's good. So now I'm going to go down to this. It has to be a 0. So I'm going to go row 1 times minus 1 plus row 2, replacing row 2, just like you've seen us do before. So let's go ahead and do this step by step. If you could work ahead of me, you can get some practice in. So row 1 times negative 1 plus row 2. All right, when I do that, I get the first row and the third row unchanged. So I always try to avoid mistakes by putting those in first. And the only one that changes is this one. I multiply the first row by negative 1 and add it to the second. And when I do that, I'm going to get 0, 1, negative 1, negative 1, 0. Wait a minute, there's a 1 there. So 0 plus 1. Don't want to make a mistake in the first row. All right, so it was negative 1 times 0 plus 1, which is just a 1. And we're going to get 0 there. All right. So now I'm going to deal with this. So I'm going to do negative 6 times row 1 and add it to row 3, replacing row 3. So this is repeat here. So when I do that, I'm going to get the first row and the second row in, unchanged. And now -6 times this plus this, -6 times this plus this, and so on. -6, -6 times 0 plus 0. Okay, so, all right, on the next step, trying to get to row echelon, reduced row echelon, I want this row to, this starts with 1, I want this to be a 1, it already is. So now I have to adjust above and below. I don't think it matters which one we do first, since we're used to doing the ones below. I think I'll do -4 times row 2, add it to row 3. So I'm working on this element. I'm going to replace row 3. -4 times row 2 plus row 3. All right, so 1 minus 1, 0, 1, 0, 0. All right, then I get the second row in unchanged. And now, -4 times row 2 plus that, minus 0, -4, 0, -4 gives us a +4 and a 1, and -4 times 1, -4 times 1 is -4, and I got lost. I'm sorry, I'm row 2. -4 times -1 is 4, and a plus a -6 is a -2. Gives me a -4, and that gives me a 1. All right, now a couple more steps. We want to do reduce row echelon, so I'm going to change that to a 0. So I'm going to use this to do it. So it's row 2 times 1. Actually, I'm not changing that at all, plus row 1 replacing row 1. So let me zoom out a little. I'm losing a lot of the picture. All right, so now I'm going to repeat the last row. And row 2 is going to be unchanged. All right, row 2 plus row 1 replacing row 1. 0 plus 1, 1 plus -1, -1 plus 0, -1 plus 1, 1 plus 0, 0 plus 0. All right. All right, with that, then I will see if you know which element I'm going to go after next. Because it's reduced row echelon. Okay, timer went off, so I'll shut this down and we'll finish on part 2. So be right back.